So an empirical formula is the formula of a compound found using lab data. So what you do is that you measure a compound in an experiment. You measure how much of each part of the compound you have, and then using those numbers you determine its formula. That's an empirical formula. Now generally there are 4 and sometimes 5 steps to doing that. Step 1, figure out how much of each element or component you have in the compound. Step 2, convert those masses to moles. So you want to go from mass to moles. And you would do that by doing mole conversions. So to go from grams to moles, you divide by formula mass. For an element, its formula mass is its average atomic mass from the periodic table. So you convert your masses to moles. If the masses or the amounts are given as percents, you just pretend each percent is a mass. So let's say we have a compound that's 70% iron and 30% oxygen. We just say, okay, we got 70 grams of iron and 30 grams of oxygen. So you convert mass to moles, that's step 2. Step 3 is where we get the subscripts that go in the chemical formula. What you do in step 3 is you divide each of the mole amounts from step 2 by the lowest of those mole amounts from step 2. And what you get there are the subscripts that go with each element. Step 4 then is you write your formula with the numbers from step 3. Now when you do step 3, if the numbers you get as subscripts are whole numbers or within a few hundredths of being whole numbers, then you can round and you use those as whole number subscripts. Our subscripts always have to be whole numbers because it's always whole atoms that combine with whole atoms. You don't have part of an atom that combines with other atoms. If the subscripts from step 3 are not close enough to round, then you have to do this, if necessary, step 5, where you multiply all the subscripts by a small common factor so that they all become whole numbers. Then you write the formula using those numbers. Let's look at a few examples. So in the first example, we have a compound with 88.8% oxygen and 11.2% hydrogen. So step 1, those are the amounts we're working with. 88.8 grams of oxygen, 11.2 grams of hydrogen. Again, if you're given percents, just pretend they are masses. Step 2, we're going to convert those to moles. So for oxygen, 88.8 divided by 16.00, and that gives us 5.55 moles. Okay? For the hydrogen, it's 11.2 divided by 1.01, and when we do that math, we get 11.1 moles. So in step 2, you convert your masses to moles. We have 5.55 moles of oxygen, 11.1 moles of hydrogen. Step 3 then, we get our subscripts. So the oxygen subscript, we're going to divide 5.55 by the smallest of these 2 numbers from step 2. The smallest is 5.55, so we're dividing the number by itself. And we get a subscript of 1. For the hydrogen, we'll do the same, 11.1 divided by the lowest of these 2 numbers. Again, we said the lowest is this one, so 11.11 divided by 5.55. When you do that, you get 2. Actually, I think it's like 2.00 something, but you can round that to 2. So these are whole numbers. So now we don't have to do that if necessary step 5. We simply go to step 4 and we write out our formula, HO. H gets a subscript of 2. O gets a subscript of 1, which you don't have to write. So the formula is H2O for this compound. And there you go. It's the empirical formula. That happens to be water, by the way. Okay, so let's try one more. In the second one, we have 83.60% carbon and 16.40% hydrogen. Okay, so that's step one, our amounts. We're just going to pretend that's grams of carbon and then that's grams of hydrogen. Okay, now step two then, we're going to convert to moles. So 83.60 divided by 12.01 and 16.40 divided by 1.01 for the hydrogen. Let me label these again. This is carbon and this is hydrogen. So when we convert to moles, we get 6.96 moles of carbon and we get 16.24 moles of hydrogen. So that's step two, convert to moles. In step three then, we're going to divide each of these by the lowest of the two numbers. So the lowest of these two numbers is 6.96. So for carbon, 6.96 divided by 6.96, that gives us 1. So initially our subscript will be 1 for carbon. For the hydrogen then, 16.24 divided by 6.96. That gives you 2.33. Now the issue here is that this is not a whole number and it's not close enough to round. You can't simply round that to 2 to be your subscript, okay? So in this problem, we have to do that optional, or not optional, but if necessary, step 5. Here, step 5 is necessary because this is not a whole number. So we'll start with 2. 1 times 2 is 2 for carbon. 2.33 times 2 is 4.66. That still doesn't work. 4.66, not a whole number, not close enough to round. So we'll go on to 3. And this is what I tell students when you have to do that if necessary, step 5. Start by multiplying your subscripts by 2, and then try 3, and then try 4, until you get a number that works. So we'll try 3. For the carbon, 1 times 3 equals 3. And for the hydrogen, 2.33 times 3 is 6.99. Now that is close enough that you can round it, and you round that up to 7. So now we have whole number subscripts that we can use for the formula. So going back to step 4, we write out our formula with these numbers as our subscripts. So the formula, C3, 3 goes with the carbon, H7, the 7 goes with the hydrogen. And those are empirical formulas. Again, formulas based on data collected during lab experiments.